Chapter 15.3, Sampling Distributions. So let's recap. So you have a population, and you want to find out what the population mean is. So to do that, you take one sample of size n, and you have the sample mean from your sample, and you use the sample to estimate your population mean. You know that your sample mean is not exactly going to be the same as the population mean. So the question is, how close is the sample mean to your population mean? In other words, how good your sample mean is. Is it a very good estimate, or it's not a very good estimate? So the idea is this. You compare apples with apples. So you have an apple. How good is this apple? Well, you compare your apple to all other apples. You have an orange. How good is this orange? You compare your orange to all other oranges. And now you have a sample mean. How good is this sample mean? You compare your sample mean to all other sample means. Okay. Now what does that mean? Compare your sample mean to all other sample means. So let's go back to the beginning. So you have a population. So you take one sample. And for sample, you decide that your sample will have 3 observations. So size is n. And then you have a sample mean. We call this sample mean 1. Then you take another sample. So this is your second sample, another sample with the same size. Now, this time you have another sample mean. So you keep this process. You take a third sample with the same size, but since you have different individual observations in your third sample, so you have a different sample mean. So you keep taking many samples. Each time you have a different sample mean. So you can have many sample means at 1001 and so on and so forth, okay? So mathematically, we say that you take all possible samples of size n, which is 3. So you keep taking many samples. So you have many sample means. So once you have all these numbers, meaning all these sample means, then you can draw a histogram of all these sample means. Okay. Now, for example, let's say the first sample mean. Let's say mu is the mean commute time of all USF students. Okay, so you want to find the average commute time of all USF students. So let me get rid of that. Okay. So the first sample mean, let's say you have 3 students, and in that sample mean, the average commute time, let's say, is 90 minutes. Okay, so I'm just making up these numbers. You take another sample mean with another 3 different students, and the average, let's say, this time is 27 minutes. And you take another sample mean, the third sample, I'm sorry, you take another sample, and this time the sample mean is 15 minutes. So you see all these sample means are different because you have different individuals in each of these samples, right? So you have a bunch of these numbers, 19, 27, 15. So what you can do is you can draw a histogram of all these numbers. That means, let's say, you have all these classes from 0 to 10 minutes, from 10 to 20 minutes, from 20 to 30 minutes, so on and so forth. And then you count how many sample means are within 0 to 10 minutes. Let's say 1. And then you count how many sample means fall within 10 to 20 minutes. Let's say 4. And you keep counting how many sample means fall within 20 to 30 minutes. Let's say this is 11. So once you have this distribution table, then you can do your histogram. So the x-axis this time is sample mean, x bar, right? Because all these numbers are sample means. And the y-axis is count or frequency. Then you can do your markings. So this is 10, 20, 30. Then you can do your bars. So the first bar is just 1. Take for example, this is the second bar is 4. The third bar is 11. Okay, so on and so forth. So this histogram, this is a histogram of sample means. We have a unique name for it, a new terminology. We call this histogram the sampling distribution of sample means. Okay, so sampling distribution is a big term. Basically, just means histograms. So let's go back to our chapter title. So again, sampling distributions sounds really big, but it just means that histograms of sample means. And that is the main idea of chapter 15.3. Next, we're going to do some classwork.